Good afternoon, ladies and gentlemen. My name is Noel Mueller, and I'm here today presenting the results from the Singapore Chinese Health Study on age at menarche and risk for CVD mortality. I'm working at the University of Minnesota as a CVD predoctoral fellow and also working on my PhD. Today I'm going to go through our hypotheses as well as background as well as hypotheses about the relationship between age at menarche and CVD mortality, including ischemic heart disease mortality and cerebrovascular disease mortality. I'll talk quickly about the methods that we went in implementing the study design, the analyses we used, the results that we found in the study, and discuss a little bit the results. So, we've seen in several populations now that there is a secular trend in age at menarche. This is also true in the Singaporean Chinese population, where from the birth cohort 1919 to 1954, over 35 years, there's been a declining mean age at menarche from 15.5 years to 13 years in the 1954 birth cohort. Other studies have shown consistently that later menarche is associated with better metabolic profile, or conversely, earlier menarche is associated with cardiometabolic dysregulation. Yet there is sparse data on cardiovascular disease hard endpoints such as mortality, and there are even fewer studies that have been done in Asian populations. So, with this information, we set out to explore and examine the association between menarcheal age and CVD mortality, including ischemic heart disease and cerebrovascular disease. And as you can see here from the directed acyclic graph, there are a lot of interactions and perhaps confounders that may make answering this research question difficult, but we feel like with the Singapore Chinese Health Study, the variables that we had at hand were good enough to help us answer this question thoroughly. The Singapore Chinese Health Study is comprised of two major dialect groups from Chinese in Singapore, the Hokkien, which originated from the Fujian province, and the Cantonese, which originated from the Guangdong province. In the baseline interview from 1993 to 1996, we interviewed door-to-door the participants, 83% of which responded and were given a structured, scannable, readable questionnaire by the interviewer. On that questionnaire, we elicited information on reproductive variables, recent history of health outcomes such as diabetes, cardiovascular disease, cancer, and other factors such as lifestyle factors and demographic factors. In the study, we ascertained cardiovascular disease mortality and ischemic heart disease mortality with the nationwide registry of birth and death in Singapore. We validated the deaths through 12/31/09, and in the population there was negligible loss to follow-up. The primary cause of death was here given in these ICD-9 codes. For the statistical analysis, we excluded anybody who was missing menarche data and also excluded anyone who was had a history of smoking, because smoking is such a strong negative confounder between CVD mortality, age at menarche, and also obesity, which may be a mediator to the association. And there are only a few smokers in the population, so it kept we still were able to have enough power to look at the association that we were interested in. The age at menarche categories we used were less than or equal to 12 years, 13 to 14 years, 15 to 16 years, and greater than or equal to 17 years. We used Cox proportional hazard methods to look at our regression between age at menarche and CVD mortality, and we used the likelihood ratio test statistic to assess interaction by birth cohort, menopausal status, and weight status. In Model 1, we adjusted for age and gender. Model 2, we included demographic variables, lifestyle variables, and all reproductive variables. And in Model 3, our mediator model, we included baseline BMI in 5 categories. The results of our analyses fleshed out this association that other studies have also seen. There was a trend, first of all, a strong secular trend for age, with older participants falling into the greater age menarche category. Also, there was a slight trend in decreasing BMI as age at menarche increased. Strong trend in education as well, and this we attribute to the cohort effect. And there were other trends in physical activity, alcoholic drinks, menopausal status, use of hormone replacement therapy, oral contraceptives, and number of kids. In our table 2, we wanted to quantify the association between menarche and CVD mortality risk factors. We saw a consistent trend in increasing age at menarche categories with decreasing risk for hypertension, diabetes, and obesity. And finally, in our last table, here you can see that increasing age at menarche is associated with a graded decreased risk of cardiovascular disease mortality. And this is driven mainly by our mortality in ischemic heart disease. And you see that, again, there's a graded linear trend with each 2-year increment in age at menarche associated with a 14% reduction in ischemic heart disease mortality. And for cerebrovascular disease, we didn't see a significant trend. There was some suggestion of trend, but we weren't able to differentiate ischemic cerebrovascular disease from hemorrhagic. And that's what we believe may have clouded our association there. We were also interested if there was an interaction by birth cohort. We looked at 2 birth cohorts, different stratum, and found that there was no evidence of an interaction by birth cohort. And with this, we were intrigued to compare it to other studies who had also looked at the association. Here you can see in the EPIC Norfolk study, similar associations were found with CVD mortality risk factors, and also similar associations were found with incident CVD and incident coronary heart disease. Another study looking at the association was the Adventist Health Study in 1976 to 1988, and they again found a decreasing trend for